Now that our scene is modeled, we can start working on a general setup in order to work with Vray. Select our engine from the renderer list. Let's reduce the threshold a bit and activate the denoiser. You have several choices, but usually I prefer the Intel OpenImage denoise. Let's set an output format. We can start with a small image for our test. A personal advice is to customize your Cinema 4D interface according to your needs. In my case, I created a custom layout with all Vray elements I use frequently. I have a general layout and then a specific one for render test with integrated frame buffer window. To customize the interface is very simple. Right-click on the interface and choose Customize Palette. Then look for the Vray elements you need and drag and drop them wherever you would like them. Let's add a Vray physical camera from my palette. Select the focal length to something like wide angle. That should work nicely in this scene. Now add the Vray physical sun sky. Notice that in this build the improved sky model has been renamed PRG Clear Sky and is set as the default mode. We will talk about post-production at the end, but we can start right away with some basic tone mapping so that we can already have an idea of what the final image will look like. So we are going to compress highlights a bit through an exposure layer, add a filmic tone mapping layer. Usually I use either the default Able or Agile Dawson preset. And finally add the lookup table layer with a photographic LUT. You can find many of them online. In this case, I'm using a Kim Amland LUT file. Don't forget to select the correct color space and save in image option. As you can see, the image looks a bit too bright because we need to set the camera to work in this sun condition. When we have a clear sky in daylight, we can always start with a simple photographic rule called the Sunny 16 rule. Basically, you set both ISO and shutter speed to 100 and then set f-number to 16. Once we have set our scene with camera and light, we can move on and start adding the main shaders to our scene. For the materials, we will proceed like for the modeling. We will just build the main shader and we will add the details later. Here I already applied a couple of default materials to the model and now we can see how to build them while using the interactive rendering. Let's start with a simple glass shader. Under diffuse, choose a black color, set reflection to white color, and for best results don't forget to activate reflect on backside. Still a white color in the reflection layer. You can use an index of refraction between 1.5 and 1.7 depending on the glass, and your shader is ready. Now let's see how to build the concrete material for the wall. Load the concrete diffuse texture in the diffuse slot. For still images, I always prefer to set sampling to none, or when using Vray bitmap to sharp mipmap in order to get crisp details. Activate the reflection by choosing a white color. Then load the specular map in the glossiness slot and a bump map in the bump slot. If you have one, you can also select a reflection map inside the reflection texture slot. Let's see if the concrete material works nicely. It is always a good rule to check how the materials work under different lighting conditions and camera views, so that we are sure it behaves properly. we can see that the glossiness map is doing its job with the sound reflection. I would like to remind you that in this follow along scene I added 4K texture, but the original texture are built in 16K resolution. As we can see, there are plenty of details, but even with a 4K map, it does its job very well. Let's check also here in the shadows. It looks good, but we can also add a bit of sheen, so that the material will get a softer look at the glazing angle. It's a very subtle difference, but it will help for sure. Now we can move on to another concrete material, this time for the floor. We will follow the exact same procedure as before. Load the correct texture in the diffuse, specular glossiness and bump channel. Apply the material on the floor object in cubic projection, just like the other two materials. Since the physical sample used to build this texture was about 300 centimeters, we can scale the texture a bit to 150 centimeters. Now we can create a basic pebble shader. In this case, we will do things slightly differently. We will load the texture inside the Vray bitmap shader to get the best out of the TX file format. These kind of files are great, since Vray will be able to load the multiple resolution of the texture depending on the view, and this can save resources and speed up rendering. We will also add a layer shader, so that we can add a baked ambient occlusion texture on top of the diffuse. We obviously also need the displacement, but we will talk about it later. Apply the texture to the planes with a flat projection and scale it slightly bigger to around 110 centimeters. Set a correct rotation to -90 degrees and your shader is ready. Now we are ready for another concrete shader, for another pavement. I use the same technique as the previous one. Here we have yet another concrete. The surface is this kind of effect that we are going to simulate with a custom map. For the rest is a traditional shader with diffuse, specular and some sheen. There's also this stuff here, but we are going to do that later, when we will add the details to our scene. We can speed up the video and move to another material. Now we are going to build this shader that looks like frosted glass. In reality, this is just a sticker applied on the glass surface. So we are going to build it exactly that way. We have these two-dimensional letters with a minimum offset from the glass, just to avoid overlapping surfaces. Start by duplicating the glass material, call it frosted glass thin. It's built exactly the same way, but we can disable reflect on the back side and lower the glossiness on both reflection and reflection slots. Then we need to activate refract thin wall. Apply the material to the letter and it's done. Now we can move on to the pillars and create the shader. It has a metallic-like paint effect with a rough surface. We can build it in two ways. Let's try first with a metallic-like shader. Start with a gray diffuse, then under reflection set color on white. We set metalness to 1 and lower glossiness quite a bit. When you use metalness, your Fresnel IOR is usually very low, just a little over 1. Now we can load the bump map. We can simply reuse this concrete bump texture here. This is a little too much, so we can lower it to 0.05. And it looks better. We can also increase slightly the glossiness value. Apply the material on the pillars and see how it looks. We are using UVW mapping and we need to scale it a bit on the V tiles. The scale now seems correct, and here we have our shader. Now we can try another option to build this shader. We will use a non-metal approach. Let's duplicate the metalness material. Go to reflection, lower the metalness value to 0, tail fall off to something like 4, increase the glossiness a bit. Let's make the diffuse color a little darker. And finally increase IOR to something like 3. I will thumb some value a bit and then we can test it. We can call this shader Pillars Paint. Let's take a closer look. Beside the bump effect, this version of the shader works much better than the metalness one, because essentially this is a paint and not a metal. The difference between the two is subtle, but definitely noticeable. So let's keep only this paint version. The last shader for now is a simple ground material. We will load the diffuse texture in the diffuse slot, apply the material to the objects. There is visible tiling, but we don't care, as we will cover it later with grass. Now we can lower the exposure a bit, add some bump, and then add the map in the glossiness slot. Be aware this is not a glossiness map, but a roughness map. Therefore, the grayscale value is inverted. You can simply fix this by activate use roughness option. I will complete the scene with a few other basic shader, so I will speed up the process here. Once we created the general shaders, we can then move on and see how to add details where needed. We can start with this concrete over here. Take a look at this effect over here near the pavement's cut. And if you look closer, there is yet another tiny grayish material over here. So we are going to build the shader using the blend material, where we can mix 3 different shaders for each effect. Let's go back to Cinema 4D. We can duplicate this polished concrete, and we can call it concrete polished 1B. Now I'm going to tune the shader to fit my needs. We will need it to be a bit darker and shinier. Now we are going to build this lighter grayish material. We can always start by copying the previous material, and we can call it polished concrete 1C. We are going to modify this shader to make it much brighter and more opaque than the previous one. Now that we have quite a few cement materials, we can start organizing them through the Material Manager's layers. Select them and add them to a new layer. Now let's create a blend material where we can load the 3 components. Just add a couple coat materials and load the components in the slots. The most interesting part of the blending is going to happen here inside the blend amount. The best way to see the blending effect is to use some basic material with very different colors that will then be substituted with the final shaders once we are satisfied with the result. Here we have our 3 shaders, red, blue and yellow. The difference between these basic materials is a lot more visible than the difference between these 2, for example. Let's load these 3 new basic material inside the blend material. We will also use a cool new feature of the new release, that is the render mask in object mode. Drag and drop our object inside this area here. And now we can start the interactive rendering. Don't forget to assign the blend material to the object. We can now disable the second coating layer by bringing opacity to 0 or just unchecking enable. We are going to load the shader here inside the blend amount slot. The radius is too big compared to what it is in reality, so we can turn it down to 10 centimeters. We can then invert normal, since we want the effect to happen only on the corner of our solid. Now we need to play with various settings. because we don't want this kind of soft transition between the yellow and the blue. We want it to be very clear. First thing, we can play with the distribution setting, use a sharper fall off, but most time this will not be enough to obtain our effect. And as you can see, it's still very smooth. So we are going to modify the contrast of the dirt shader by loading it inside the filter. We will keep playing with the parameters of the filter shader until we reach the result we desire. If by any chance the correction of one filter shader is not enough, we can always add another filter shader to get an ever stronger contrast. We finally get this sharp transition between the two materials. Our transition line is totally straight, when in reality it's quite wavy. We can fix that easily by inserting a noise texture inside the dirt radius slot. We can play a little more with the parameters until we get something similar to the reference image. Okay, now this is looking much better, and we can move on to our second coating layer to build this grayish material here. Turn the opacity to 1, and we will use exactly the same techniques and adjust the radius, noise, scale, and fine-tune other settings where needed. Once you obtain the correct result, you can reload the final shaders and you are done. Let's do a test render. And everything seems to work nicely. Probably we'll still need to lower some more, a bit more the radius and noise scale. And now everything looks better. Now we can add the details to this floor concrete. We will use once again the render mask mode with the floor object. Start the interactive render and add dirt multiplied over the diffuse texture using the layer shader to get a darker border. If you look at our diffuse filter render element, we can see that the texture tiling is continuous between the floor elements. Therefore, we will try to fix this continuity by using a MultiSub text shader and the new UVWRandomizer. Upload the Vray MultiSub text, and in the texture list we have our layer with diffuse and dirt. Under General, we can randomize the gamma by increasing the value and select random by mesh elements. Despite being a single object, each floor element will get a random gamma value. If If you don't like the result, you can always use the seed to generate a different option. In this case, there is a way to match difference for our purpose. You want it to be barely visible, so I will lower the gamma value to something like 1. The difference it is still there, but it's not too much. Now we need to resolve the texture tiling issues between the floor elements, and we are going to use the new Vray UVWRandomizer for that. Always select the random by mesh element, and then you can play with the settings to give you a random scale, rotation and position. Right now this texture doesn't have a lot of contrast, so I'm going to show you the use of the Vray UVWRandomizer using a texture with much more visible tiling. For example, we can apply this shader to our geometry and then zoom in. As you can see here, the texture continues from one element to the next, so we are going to play with the values to break this continuity. We can scale it a bit. The rotation is already at 360 degrees. As you can see, now it's working perfectly, and the texture is positioned differently from one element to the next. We can obviously load the MultiSub text to introduce even more variety between the elements. Shader details are important, but geometry details are just as important. If you look at some reference images of the museum, no matter where we look, there will be always plenty of geometric detail. We have security cameras, trash can, manholes, neon light installation, floor lights, labels on the floor, fire hydrants, other floor lights, grids, this object here, and many other objects. I tried to model most of them and are ready with the shaders in another scene. We have these beautiful concrete benches with nice geometry and texture details. This is another concrete bench. A metal grid, fire hydrant, info totems, manhole, labels. As you can see, some might look like very simple objects, but when you sum them all up in the scene, at the end it will look a lot more realistic. Here we have a security camera, the gate blinking light, the reception desk, and the other artificial light bodies. This is our very detailed neon light installation. some photos for the museum exhibitors, and I want to thank my friend Giorgio Locatelli for letting me use them. Even with the objects, never forget to add the right details. Here you can see how I layered the various shaders one on top of the other. As a base material, I use one of my shader from my metal collection. Let's quickly see how it is built using the metalness workflow with a correct diffuse color, correct IOR, a glossiness texture, and some anisotropy. On top of that, I added some generic dirt. It's a very simple shader, but it will add detail. Don't forget to select add material here, so that it will be added correctly to the metal base. Then we have this kind of splats over here, and then finally the map with the text and graphics. Now we added all our previous objects to our scene, and they work really well. Something that is noticeable right away is that our pebbles are totally flat. We will add the displacement to get nice geometric details. Our shader has been applied in flat projection, and since we want the texture to be in UVW projection, we can select the objects and the texture tags and select assign UVW coordinates. As you can see, now we have a correct UVW projection that will help us with the use of displacement. Add the Vray geometry tag, enable displacement. Under texture, let's load the Vray bitmap and select our pebble displacement map. Select a linear color space, since it is a 32-bit TX file, and increase the displacement amount to around 3.5 centimeters. Since the surfaces are totally flat, we can select the 2D displacement mode. To get the best results, you should always set the texture resolution to the native resolution of the texture used. That in this case is 8K, but for our render 2048 pixels are enough, and we will save some resources. For a totally flat surface, we can set the precision to 1, then drag the texture tag inside the slot here. You can then copy the Vray tag to all the other objects. Now we can start our interactive rendering and see how it works. It will take a few seconds to start, since the engine will need to compile all the displacement geometry before starting the render. Once the render starts, the interactive rendering is smooth, despite all the detail here. There are some minor issues. We can fix it by increasing the texture resolution to 8K, but we are not going to see the pebbles so close, so we can leave them as they are. A great thing of the Vray displacement is that it is extremely efficient if correctly used. Don't forget that this is quite a large area, about 1000 square meters of pebbles, and we are barely using 15 gigabyte of RAM. We can check the bump normal channel, and you can see it is working really well. Now we are going to see this expanded metal here, used for the gates. Thankfully, I already had a similar shader in my Vray metal collection. It's available for both Max and Cinema 4D Vray. We also have several free sample shaders, so be sure to check them out. Let's look for our metal shader. It's this expanded metal here. We are also going to use this galvanized metal for the gates frame. We applied just like we did with the pebbles. Let's do a render test. There is also the museum logo over here, but it is on the outside and we are not going to see it. Here we can see through the bump normal channel that it is working beautifully. If we look at the scene, you can notice that natural elements are missing. We are going to put some grass over here, and trees and hedges over there, and we will use some Cosmos assets. Let's open our Cosmos browser. It is really an amazing feature of Vray. We have plenty of models that we can use for free. If you look closely, you can see that some of them are flagged. That is because I have already downloaded them. You can also choose this option so that you can see only the model you have already downloaded. In this scene we are going to use this tree over here and this hedge. If you look inside the tree model, you will also find a close-up render of the object. Once downloaded, click on the green icon and it will be imported in our scene. Now we can position our tree. As you can see, it may look like a low polygon model, but if we set the preview to full geometry, we can see all the details. If needed, you can also make it editable. The best way to duplicate is to create a render instance or a multi-instance. Of course, the copies looks absolutely identical, but we can select them and randomize a bit the scale and rotation so that we can obtain some sort of variation. Of course, this can also be done manually if needed. You can start the interactive rendering and they will just work. I already distributed all the trees needed in a separate scene, so I will just copy them here. We have some trees here in the background, some here, and some edges over here. We haven't finished with the Cosmos library, as we will use it to insert some cars on the roads outside the museum. We have many models to choose from small city cars to bus. Again, I have already distributed them in a separate scene, so I will just copy them here in this one. I positioned some over there and some over here. Again, they look like low polygon, but if we set the preview to full geometry, we will see all the details. Of course, if you need, you can change the materials. They are just normal V-Ray shaders, so you can tune whatever you want. Color, reflection, or whatever. Now let's talk about the grass. The best way to fill an area is to distribute a small chunk of blade of grass like this one. I will use the C4D cloner object to distribute it. Insert the grass inside the cloner. Set in object mode and drag and drop the grass base object over here. The clones are distributed nicely over the surface, but obviously are too few. When dealing with large amount of clones, it is best to set the viewport mode in points, so that we can keep working smoothly in the viewport. Now we can increase the count number to 4000. In reality, they are not so many, so we can change the viewport mode back to object. The clones are distributed nicely over the surface, but if we zoom closer, we will notice some sort of tiling, because the clones are all aligned the same way. We are going to fix it by using this random effect here. We don't care about randomizing the position, so we can turn it off. Now we can activate only rotation on the vertical axis. And a bit of scale. And now it works perfectly. Let's do another render test. We have this beautiful subsurface scattering here. For this I've used the new thin walled option rather than the traditional two-sided material. I haven't tested this method much, but it seems to work really well. Another detail that we can add to our scene are leaves. If we look around, we can see they are distributed everywhere, especially during some season. I created a few leaves here. They are just low polygon model, but the geometry is enough to catch the shadows correctly. To distribute them, we will use a really fun tool that is called the Scatter Pen tool. You just select your objects and you can paint wherever you want. It's very easy. If by any chance you scatter the leaves in the wrong place, you can use the tool in remove mode and delete them easily. Now let's start the test render. And as you can see, even if they are a small detail, they really enrich the scene. You can also see that our bus over here and other Cosmos assets over there are filling the background nice.